Solving radical equations is very similar to solving any other algebraic equation in that you essentially just want to get the x by itself by undoing what is being done to it. For example, in this simple algebraic equation, we have a 4 that's being added to the x. So to get the x by itself, we want to undo that plus 4 by doing the opposite of adding. We subtract from both sides. So by getting the x by itself, we find out that x equals 6. So when we solve a radical equation, it's the same thing. We want to get this x by itself, but before we can do that, we need to undo the radical by simply squaring it. That undoes this sign right here, like the kind of house check mark thing. But before we can square it, we need to get it by itself on one side of the equal sign. So before we can square this radical, we want to subtract 3 from both sides. So then we have square root of x equals 11 minus 3, which is 8. Now we can square both sides. So now, once we square this cancels this out, and all we have left is what's on the inside, which is x. So we have x equals 8 squared, which is 64. Okay, so same thing here. We want to get the radical by itself on the equal sign before we can undo the radical. So we have a minus 7 on the outside of the square root sign. So that means we want to add 7 to both sides. So then we have square root of 4x equals 1 plus 7, which is 8. So now we can undo this radical, and the way we want to do that is by squaring both sides. So what we have left is this on the inside, so we have 4x equals 8 squared, which is 64. Okay, we're still not done because we are trying to solve for x. We want this x all by itself. So 4x is the same as 4 times x, and the opposite of multiplying is dividing. So that means we want to divide both sides by 4, and x equals 16. So this one is pretty simple. You just have square root of x equals 12. The radical is already by itself. So we are just going to square both sides, and this square cancels out this square root sign. And so what we have left is this x. So we have x equals 12 squared, which is 144. Okay, so in this one we have a radical on both sides. We don't have anything on the outside. So what we want to do is we just want to cancel both of these out. So this cancels this out, and this cancels this out. And what we have left are the parts on the inside. So we have 3x plus 5 equals x plus 1. So what we want to do is get all the x's on one side and all the numbers on the other side. So for me, the easiest way to do that is to subtract the smaller x from both sides. So we have 3x minus 1x, and that's 2x. So we have 2x plus 5 equals 1, and we want all the numbers on the opposite side from the x. So we're going to take this 5 and subtract it from both sides. So then we have 2x equals 1 minus 5, which is negative 4. And 2x is the same as 2 times x. So we want to divide both sides by 2. So x equals negative 4 divided by positive 2. Anytime you have one negative and one positive, you are going to get a negative number. So x equals negative 2. Okay, we have 2 equals the square root of x plus 6. Even though there's a plus sign here, we can't do anything about it until we get rid of this radical. So we want to cancel this out by squaring both sides. So we have 4 equals, and we are going to just have the inside left, so x plus 6. Now we want to get x by itself, and there's a plus 6 attached, so we want to minus 6 from both sides. So 4 minus 6 is negative 2, so we have negative 2 equals x. square root of x plus 8 equals 9. Now the plus side is on the outside of the radical, so that means we want to get rid of this plus sign before we can square both sides. So we are going to subtract 8 from both sides. Okay, so we have square root of x equals 9 minus 8, which is 1. Now that we have the radical by itself on one side of the equal sign, we can square both sides, and that means we have x equals 1 squared, which is just 1. Okay, we have square root of 2x plus 3 equals 5. Once again, this whole equation is on the inside of the radical. So before we can subtract 3 or divide by 2, we need to get rid of this radical sign by squaring both sides. So this square and this radical cancel out. So we have 2x plus 3 equals 5 squared, which is 25. Now we want to get rid of this plus sign by subtracting 3 from both sides. So we have 2x equals 22. We want to get x by itself, but there's a 2 attached. And anytime you have a number and a variable that's just squished together, they're basically being multiplied. So in order to undo that multiplication, we want to divide both sides by 2. And 22 divided by 2 is 11. Square root of 3x minus 5 equals 4. So since this minus 5 is on the outside of the radical, we want to bring this over to the other side before we can get rid of the radical that is housing the 3x. So we get rid of minuses by adding, because the opposite of subtracting is adding. So we add this 5 to both sides, so this and this cancel out. So we have square root of 3x equals 4 plus 5, which is 9. Now we can square both sides to get rid of this radical. So we have 3x equals 9 squared, which is 81. Now we want to divide both sides by 3. So x equals 27. So we have x minus 4 plus 3 equals 9. So since the minus 4 is inside the radical and the plus 3 is outside the radical, we want to subtract the 3 and bring it over to the other side before we get rid of the radical. But we're going to get rid of the radical before we can subtract the 4, since the 4 is inside the radical. So first we're going to subtract 3 from both sides. So we have square root of x minus 4 equals 9 minus 3, which is 6. Now we're going to square both sides. So what we have left is the part on the inside, since the square and the radical cancel out. So we have x minus 4 equals 6 squared, which is 6 times 6, that's 36. Now we want to undo this plus 4 by, undo this minus 4 by adding 4 to both sides. So x equals 36 plus 4, which is 40. X equals square root of 60 minus 7x. Since this whole equation is on the inside of this radical, we're going to go straight ahead and square both sides to undo this radical, because before we can take care of pluses and minuses that are within the radical, we need to get rid of this outside house first. So we end up with x squared equals 60 minus 7x. So anytime we have an x squared and just a regular x and a number, we can't just put the x's on one side and the numbers on the other side. What we need to do is get all three terms on the same side to make a trinomial and then factor it. So what we're going to do is, since this is minus 7x, we're going to add 7x to both sides. And since this is positive 60, we're going to subtract 60 from both sides. So we're going to have x squared plus 7x minus 60 equals 0. Now keep in mind that we can't combine this x squared and the 7x because the x's have different exponents, so they're going to stay separate. Now that we have this trinomial, we can solve by factoring. So we're going to make two parentheses. Okay, and we're going to look for two numbers that multiply to equal negative 60 and add to equal positive 7. So if we go down here for a second and think of 60, what are our factors? We have 20 times 3, but that adds to equal 23. We have 6 times 10, but that adds to equal 16. Actually, this is negative 60, so we want one positive and one negative. So we're actually subtracting instead of adding. So negative 60. So we have negative 20 plus 3, that's negative 17. 6 plus negative 10, that's negative 4. We have negative 12 plus 5, that's negative 7, but we're looking for positive 7. So what we're going to do is we're going to switch the signs. We're going to say positive 12 plus negative 5, and that's going to give us a positive 7. So when we go up here, since we have positive 12, we're going to say x plus 12 and x minus 5. Okay, now that we have this factored, we can set both of these factors equal to 0 and solve. So we have x plus 12 equals 0, or x minus 5 equals 0. And we want to get the x by itself, so we're going to subtract 12 from both sides, and we have x equals negative 12, and then we're going to add 5 to both sides. So we have x equals 5. So these are two answers for this problem. And that is it for solving radical equations.